So as the topic shows that we're looking into how to implement different data partitioning methods for model building in WEKA. So we're going to be more particular about WEKA. How do we do it in WEKA? That is, how do we are indirectly asking the question, how do we evaluate our models? Why, or how do we build and evaluate models? And like I said, as we are seeing this series of real-life applications of machine learning to different fields. So, and as people already started groupings, try to work on ideas that they could possibly implement. So this is one of the recurring questions and clarification that we kept getting from our members. So that what are the different ways of partitioning data and how do we go about doing them in WEKA? Then I consider it necessary that we have a short discussion on this, and then also have a practical demonstration. So of it in WEKA environment, after which we're going to have questions and answers, the case may be. So as stated, how to implement different data partitioning methods for model building in WEKA, which we are practically or indirectly asking this question, evaluating models. So how do you build model and evaluate it? Because it's not just enough to build the model, you need to be able to show that the model is working. So which leads us to what we call the generalization concept. Remember the hypothesis function for machine learning that says if the hypothesis works on enough data, it will work for unseen data. This is the big idea behind machine learning. We call it the inductive learning hypothesis. So if you're able to demonstrate that your data will work on the training set enough, and the enough is a relative term, what is enough in one field might not be enough for another field. Even the same field, depending on where the data is coming from, what is enough for this might not be enough for that. Now, so that is why asking the question that is enough is a relative term. Then you have to go back to what I usually say, let the data speak. Let the data speak. So when you plug in your data, what you get is going to be what the data is telling you. So the question must be correctly asked. To be able to answer this question, how well does a learned model generalize from the data it was trained onto a new test set? So that's why we need to partition data into 2 or 3, as the case may be. And sometimes we have the cross-validation. So people usually get confused on which one is the best, which one should we use, what do we go for? So this is what we are going to try to clarify in the next couple of minutes, inshallah. So the generalization concept say once you train your model, so we need to check how is it doing? Is it doing good? Because sometimes you have very high performance measures like a high correlation coefficient or high accuracy in training set. However, the testing set is really, really bad. So when we could be talking of overfitting and underfitting, when do we declare on overfitting and when do we declare underfitting? So which is another concept that we would like to also revise with us later on, hopefully in another episode. Now, so basically in partitioning data, so we are trying to check the generalization ability of the model. That is the idea behind trying to partition the data. Otherwise, we could have just build the model and go ahead and declare celebration, we get 100% because you build the model. But then no, you don't celebrate until you have checked for the generalization ability. Because it's not just building the model, is the model able to work on data set that is coming in afresh. Now, in order to be able to do this, we have 2 main data partitioning methods. The first one, which we call the holdout method. The holdout method. Holdout means you are going to use some part of the data set while you are holding out something to be used for testing later on. So in this case, there are 2 categories of this. You see it? Holdout is divided into 2. You can divide into 3 sets. We have the training set, it could be 70%. This one could be 15, this one could be 15. It depends on the size of the data set. But if the data is really big, then 50% could be an option to use for training set, while 25 is going to be used for validation. And finally, another 25 we use for the final testing. This is when you divide your data into 3. And this is also possible in WEKA. We're going to demonstrate it, inshallah, today. You see, the popular one is the way you divide to 2, very popular among people. Just divide your data into training and test. That's all. You see, it could be 75, 25%. It could be 80, 20. It could be 70, 30. Very common, 70, 30, 70%, 30% ratio is very common. 80, 20 also common, but it could be anything. But the idea of training set is, training set should be as much as possible so that you can expose this data expose enough data to the model. Remember the definition of the inductive learning hypothesis. It said if the hypothesis work on enough data. So enough is very important. That is why I made a comment here. For you to use 50% of data for training, it means the data must be sizable, a little bit big. Otherwise, 50% might be too small to have effective training. However, if the data is big, 50% of maybe 50,000 samples or 20,000 samples, even 30,000 samples, 50% will still be something reasonable compared to somebody that is having like 100 or 50 samples or 150. So in that case, 50% of it might not be enough. So that is why it's a relative concept. So to have enough data, we partition the data, letting the training set get the majority. This is very important. Now, so the second one, the fourth one is to divide into 3. The second one is to divide into 2, depending on the size of your data. You see, if your data is sizable, this is the best to go with. It means you can have a totally separate one. You keep separate. You are not going to use it during whatever parameter search, whatever you are doing. You keep totally away from your system, as we are going to see. Whereas for this one, you have only 2. Use the first one for training and the other one for testing. It's also okay. So any of these 2 you go with is fine. However, sometimes you might have some people who has a very, very strict opinion on, they want your data to always be 3 sets: training, validation, testing. But then really there's no need to be very, very kind of restrictive on this. It is something that is valid. Somebody use 1 or somebody use 3 partitioning or use 2. They're okay, actually. And then the third one is resampling when there is few data. Resampling when there's few data. We call it n-fold cross-validation. Usually people also prefer this. If data is very small, this is the option. But if the data is coming from your client and you have enough data sets or sizable amount of data, it's good to go for partitioning. But resampling, we use it for some time to check if we have just a few data sets from a client, 25 samples, 50 samples, then we can use cross-validation to check maybe there's possibility of using this data. If we get good result, then we can tell the client that at least the data seems to be performing. You might deploy now resources to get more data set, because it takes a lot of money to be able to get data set in some industrial setting. So they want to check, does it really worth it going ahead with this project? So we get initial samples, few samples. We try to use cross validation to check what we are going to get. And then based on that, we can recommend that, okay, you can go ahead and get more samples. Now, so we say the ODAT method works in this way. You just divide your data. So either into 2 or into 3, as the case may be. So you train each model on the training set and then trace each model accuracy on the validation set or the testing set, as the case may be. People use the validation and the testing interchangeably. Now, so the first one is, let's say we develop a model using the data and the training. This is the first procedure. So you have data set, you divide into 2. You have the testing set, you have the training set. Use the training set to build your model, and then the tracing set can come back in the next stage to check. See, based on the testing set now, I'm now going to use the model I built already the training set, the training procedure to now check. Okay, if I give you this testing set, what is the predicted value? And I'm going to compare it. What is the prediction from the model? And what is the actual value given to me? I know here it is positive, negative, negative, and then positive. It means this one is correct. This one is correct, but this one there's a mistake here. Maybe this one, so there's a mistake. We compare the actual with the given. So this is when you have two partitions. You partition into two. It's valid. It's a valid procedure. And WEKA has capability for that easily. Very straightforward. For dividing into 70 and 30, or 80 and 20. So when you have three, the three set, this is where WEKA doesn't specifically tell you there are three sets, but you have to create it yourself. But the capability, the option is there. So also we're going to demonstrate this for us today to see that if you divide your data into three, how do you use WEKA to work on the three data sets? Now, so this is how the procedure goes. As you know, this is the data. So you have here, divide the data first and foremost into training set, then validation set. They are inside the model building block. The model building block is housing the training set and the validation set. It means you can train your model and check the performance on validation set. You can keep redoing it, maybe changing your hyperparameter, changing many things, doing many things. However, this testing set is never used for anything before. You don't get it involved with when you are building the model. And this is different between using 3 sets and 2 sets. You see it? So the testing set is totally outside the building block. It doesn't enter this one. So you use all your training, testing, change your hyperparameter, you do it with the training set and the validation set. And finally, once you are okay with the model you develop, now you can now bring in the testing set outside the development cycle and now check if it has been checked on validation set, it's performing. That is why you say that, okay, it's okay now. Then it's good now to go and check it finally on the testing set. And that's why it is recommended when you are going to break your data into either 2 or 3, it is good to have randomized data partitioning. That is, you break those data sets. You don't want to choose the first 500, then maybe the data set have some unique characteristics as you go down the link, actually the table. So when you randomize it, everything got mixed together. So it makes sure that your data is going to be representative of all the kind of attributes that are available in this particular model you want to do. So this is a point we need to take note of. When you partitioning the data, it's always good to do random partitioning. So following the first 100 is going to be used for training. The remaining 30 is going to use for testing. Could expose your model to weakness, which means your data is only working on a particular set. Maybe this set I've gotten from one department, another set from another department, and they arrange them in the table. So we mix them together before we partition so that the system is exposed to different types of those attributes or samples that we might have. Now, so once you have done that, this is under the partition into 3. Yeah. So before we go into this, I think let me just summarize for us, and then we go into the WEKA together, and then we can do the 3 at a time. So the third one is the n-fold core validation, which in this case, well, you partition your data into n folds. N could be number starting from 2. Could be 2, 3, 4, 5, but the common one, very common one is 10. 10 folds. If your data is sizable, but if your data is really very small, maybe you might need to go for 3 folds or thereabout. Because the idea is that this data set is made of 1,000. So we're going to partition into 10 places. 1, 2, 3, 4. This is going to be, since you have 1,000 samples, this is going to be having 100 samples. This one will be 100 sample, 100 sample, 100 sample. So what you are going to do is you are going to have use the complete set AF for training. And then this single partition, we call it fold 1, use it for testing, for validating the data. So it means use it for training, then test it on this, and then you record the result. So result number 1, that's going to be fold 1 result. Maybe you got 98%. Then the next stage, you can see second partition, part of the training set, another 100 sample here, which is already partitioned to belong to the fold, will be used for validation. Why this one will become part of the training set again. These are for training. So you keep shifting the window until you have all this. Each of the partition or fold must be used in validating the data. I say, etc. You keep doing that till the end of the number of folds you have established. This is classical example pictorially. So let's say I partition this data into 10. So each of these may have maybe 100 samples, 100 samples, 100 samples. It could be more, it could be less. Now, but if you are going to have lesser value, lesser samples here, maybe having like 3 samples here, I think it's better you reduce the number of folds. It could be 5 or even 3, depending on the size of your data set. Now, assuming everything is okay, you have 100 samples or more, or thereabout. So you use everything from air to air. Use it for training, you can see. Combine these 9 portions. That's going to be 900 samples. Use it to train, then use this one for testing, and note down the result. The next stage, second fold, use this for validation. Why this one become part of training? You do that continuously until you use the 10th fold to also check. So you're going to have 10 results. So add everything together, 96, 92, 85, and you find the average, which is going to be total divided by 10. Because your fold is 10-fold. If you use 5, divide it by 5. People I've seen students made this mistake because they are used to 10-fold. Now they decide to make a model for 5-fold, and they still divided the answer by 10. I say, no, you divide by the number of folds because you are just finding the average of the results. This is how the cross-validation actually works. Now, so having seen the way the 3 options actually works, now let's just now look at what WEKA has for us. Now, let's just look at WEKA for us. Yeah. So, see, the starting point is the pre-processing. So you need to load your data. You have to open your file. So we are loading the diabetes, our popular data set. So the data is loaded. So before you load the data, everything will be gray out. You can't use anything until you put in the data. So the data is there now. You have the inputs, and then this is the class what you want to classify to positive or negative. And these are the class distribution. We discussed all this before. Now, let's go now to classifier. This is the area we want to work on. How to partition our data. This is where we want to work on. Now, the popular one we all know is this percentage split. You see, you just state here, I want you to split to 70. It means you are splitting your data into 70% for training, 30% will be used for testing. See, just stating 70 here, you can see percentage beside it. It means you specify that 70% should be used for training, while the remaining will be used for testing. This is when you are using the 2-fold, as I explained before, 2 folds now. See, sorry, holdout method with 2 partitions, So we're using holdout method with 2 partitions, 70% for training, 30% for testing, or 80% for training, 20% for testing, or 75%. Like I said, you can always play with numbers. Some people you do it up to 90%, 10%. But personally, I see that as the training says a little bit become too majority. Yeah, we want to train as much as possible because inductive learning hypothesis says if it works for enough data, then it will work on unseen data. So that is why it's good to have enough data. So when we have only to just say 70%, and then maybe I select my classifier here. Let's go for our friend lazy k-nearest neighbor. Very simple one. So then we just say, okay, start. It's run the model for us. So you see, so this result you are seeing here is the outcome of the testing set. The 30% for testing is shown here. Usually the training set result is not shown. If you want it to be shown, you have to go to more option, and then you have to say that output model for training split. You see, show me the model output for training split, because usually it's not shown to reduce the number of information on the screen, so it doesn't produce it. But if you need it, just go here and check the box, you can see it. If you want the results to actually go to a file, you can choose where you want it to go. You want to store your result in CSV file, plain text. We discussed this one earlier on. Now, so this is how you use for just holdout method with two partitions, training and testing set. Now, then the second option under holdout is when you want to divide to 3. Yeah, this is where people have questions or concern. So because here it has for 2, 70%, it will break into 2. Then you have the third one, the second one will be used. But for 3 partitioning, what you have to do is look at these 2 options here. Look at supply test data. You see? So what you have to do is you need to break your data into 3 outside WEKA environment before you bring it to WEKA. See, what you have to do is that, because now we want to use 3 sets. So the easiest way to do is, after you randomize your data, just extract what you want to reserve as the testing. Remember that when you are using 3 partitioning, you are going to have training, validation, and testing set, which is the final one. Now try to take away the testing set out of your data. You can take it out of the Excel and put it in another file, and then reserve it there. You know the percentage you want to use. Maybe you have like 1,000 samples. You want to use like 700 for training, and then 150 for validation. So the 700 for training and the 150 for validation, let them remain inside your Excel file. Then the 150 for the final testing, the third partition, take it out of the file. This is how you have to deal with it in WEKA. So you remove the remaining testing set, the third partition, take it out of the file, so that when you are uploading your data here, when you're uploading your data, you have to upload the data that has the 700 plus 150, which is going to be 850 samples. Those are meant for training and validation only. The third sample is already removed, which is the one to be used for the final testing. So now, once you have done that, you prepare your data now into 2 files now. One file contains the one for training and validation, the first one. See, so you are going to come here again, just say here, percentage split. Don't pay attention to that. Now you are having 850 samples in your file. Out of that 850, you know that you want to use 70 of that 850 for training and 150 for testing. So now you have to take it to 100%, because now the system is dealing with your data as 100% now. So now you have 850 samples. So what percentage of 850 is going to be 700? And what percentage is going to be 150? Based on that, you are going to specify the percentage that you want to use inside the WEKA here. So let's say if you take 850 to percentage, 700 out of 850, what percentage is going to that? It's going to be, you have to give us the percentage here. Let's say, for example, it's going to be 65%, as the case may be, or maybe even 75%. Yeah, let's say 75% or even 80%. So you specify the percentage here. This is 75% that I want to use. Then the system will automatically take 75% from this file and use it for training. And then once we run it, you produce your result. At this point, 75%, which is representing 700 samples for a sample as a case study, it's already used for training, and the result of testing is now shown to you. Now you have trained and validated your data. But remember, now you have the testing set still in your system, never used. You now go to this option, supply test set. You can see supply test set. You have to now go and select the third partition that you kept secret in another file. You now click and load the file. You now open that particular file, assuming that it is inside this particular file. Then I'm going to open it, and then this is going to be used for checking. Yeah, that's the CSV file, as the case may be. Now, so it's going to load the file. So once you load the file in, then you now run it again, as the case may be. You are going to run the experiment again, and then it's going to generate the result. So in this case now, you can see that we have two stages of checking the result. We first of all train and test using 75%. We add the result. Then we now say supply the test set. This test set you kept secret, that you took out of the file before you uploaded into WEKA. Then you have to use it for the testing set. This is what you do when you are using the 3 partitioning approach for evaluating or for building machine learning models. So that's how you deal with partitioning data using ODAT method. Twofold, that is, two partitioning, very straightforward. Just use this one, that's fine. Original data is loaded, specify the percentage split, it goes. But when you have 3, you need to work on your data first by extracting the testing set and put it in a separate file. That separate file will come in later after you have built your model. Then you now say, supply the testing set. You now go to the link where you have your set, open the data set and run the experiment, and then you are going to have the result of the final testing of your model. Now, and the final option, which is when we have fewer samples, this is when you use this one, cross-validation. The one I explained, 10-fold. Just use how many fold? 1 10-fold, then it's going to run the experiment 10 times, as I said. If your data is big, using 10-fold will take a lot of time, because that is running experiment using 90% of the data and 10% for checking for 10 times. So if you have big data, cross-validation might not be an option for you, as the case may be, because ordinarily cross-validation is meant to be used when your data set is very few. When the number of samples is very, very few, you go for cross-validation as the only way option out. You can see that this is still working, actually. Something that we usually click and it's finished, but because it has to run it 10 times, it's still working. Try to split it 10 times and also take the validation as the case may be. And if you want to use 5, just specify 5 here. That, okay, I'm going to do 5-fold cross-validation. So this is how we do the cross-validation in WEKA, and also the holdout method as the case may be. So once again, we come back here again and try to let us see. This is the 10-fold cross-validation we just display. And then this is the one we talk about 3. When you have 3 sets. So you have to undo this one first. In WEKA, you have to undo these 2. By your data set is having 1,000 samples, you have to manually remove 150 and put it in a separate file. You call it, this is going to be my testing set. So keep it in a separate file. And then the remaining 700 plus 150, they are going to be in one file. And then you are going to supply this file to WEKA for training and validation. Then you now go to WEKA and select the option for selecting the supplied test set. So the supplied test set is when you are going to upload the file that you kept secret or separated from your file. So here you have to do it manually. So let's pay attention to that. I think that is where majority of people actually had confusion or they needed a little bit of guides on that. Why the two, that one is very simple. So when you have only two partitions, training and validation, or training and testing, as the case may be, because if it is only two, people use validation and training interchangeably here, which is okay. See, people say, okay, training and testing, that's fine. Some people say, okay, training and validation. But when you have three, then you have to separate the two. Training and validation first, then testing will follow finally using the WEKA environment as we have actually demonstrated. So I think this is how to partition data to implement partition of data sets in preparation for model building in WEKA environment. So if we have a question, so we are going to take a couple of questions or clarification as the case may be. Thank you all, and wish all the best, and thank you for listening. Now, so you can raise up your hand for question and or clarification or comment. Thank you.